In this section, we will talk about antiderivatives using formulas. So we'll be using formulas to compute antiderivatives. Now, first of all, the antiderivative of f of x is the set of all functions f of x plus c, so that when you take the derivative of f of x plus c, that gives us f of x. Okay, so what does that mean? It means to find the antiderivative of f of x, we find the functions so that when we differentiate f of x plus c, the result will be f of x. So here's a quick example. Let's say we want to find the antiderivative of 3dx. Okay, we want to find the antiderivative of 3dx. So we want to ask ourselves, the derivative of what will give you 3? That's the question we're asking. So if I want to get a 3, then I have to take the derivative of 3x, because the derivative of 3x will be 3. But the derivative of any constant is 0, so we're going to have some kind of constant there. That constant could be like a 7 or 11 or 13. It doesn't matter what it is, because the derivative of it is going to be 0, but it does exist. Okay, so the antiderivative of 3dx is going to be 3x plus c. Why? Because if you take the derivative of 3x plus c, it gives you 3 as the answer. Now the constant c is called the constant of integration. Anytime you take the antiderivative or the integral, you always have that constant of integration, because the derivative of a constant is going to be 0. So it doesn't show up in the antiderivative problem, but it is still there. In other words, to find the antiderivative of f of x, find the set of all functions so that when you differentiate f of x plus c, the result will be f of x. Antidifferentiating is often called integration. So this is the notation for it, the integral of f of x dx. And it equals to f of x plus c, where this is the general form of the antiderivative of f of x. Let's do some examples. In the next slide, we are going to learn how to do these using formulas, but for now, let's just kind of do these intuitively by trial and error. So we want to find the antiderivative of 6dx. In other words, we want to find out the derivative of what function will give you 6. So we know the derivative of 6x will give you 6, but then there's some kind of constant there, because the derivative of any constant is 0. So even though the 0 doesn't exist in the antiderivative, the constant did exist in the original function. So this is going to be 6x plus c. Now let's check. If I take the derivative of 6x plus c, the derivative of 6x is going to be c. Derivative of any constant, doesn't matter what it is 0. So that does check out. Whatever our answer is, when you take the derivative, it should give us 6. Next one's a little bit more difficult. We got 5x squared dx. So we want to figure out the derivative of what function will give me a 5x squared. So let's think about it like this. If I take the derivative of something and I'm left with a square, that means we had to have an x cubed in here, right? Because the 3 is going to come down, and 3 minus 1 will give you a 2. So the derivative of a cube is going to be a square. But if you take the derivative of just x cubed, it gives you a 3x to the second power. We don't have a 3, we have a 5. So how do I get a 5 in there? Well, first I want to get rid of the 3, so I'm going to divide by 3, and I want a 5, so I'm going to put a 5 on the numerator. And then we have the constant of integration. Now doing it this way, just by trial and error, is difficult, which is why in the next slide, we'll be given some formulas which will help us do this systematically. Okay, so this is 5 over 3, x to the third, plus c. Let's check. If I take the derivative of 5x to the third power plus c, then the 3 is going to multiply with the 5/3. So 3 times 5 is 15. 15 divided by 3 is 5. X to the second power, because I subtract a degree from this, and the derivative of a constant is 0. So I get 5x squared, which is what we wanted. Okay, last one is the antiderivative of x plus 3 dx. So we want to figure out the derivative of what function will give you x plus 3. Okay, so to get the x, in order to get a degree of 1, the original function had to have a degree of 2 because the 2 comes down, you subtract 1, that's how you get a 1 here. So the degree of the antiderivative was a 2. But if you take the derivative of x squared, it gives you a 2x, but we just want a 1 here. So we have to get rid of this 2 somehow, which means we divide by 2. For the 3, the derivative of 3x is going to be 3. And then we got the constant of integration, which is going to be c. So the derivative of this is going to be x plus 3. So we're saying that this is our answer. X squared over 2 plus 3x plus c. Now let's check this. Let's take the derivative of x squared over 2 plus 3x plus c. So for the first one, derivative of x squared over 2, the 2 is going to come to the front, becomes 2x to the first power because we drop a degree over 2. Derivative of 3x is going to be 3, and then c is a constant, so that's going to go to 0. 2 over 2 is 1, so this does give us x plus 3. But again, doing it this way is time consuming. It's, like you have to do some trial and error, you got to do a lot of thinking. So instead, here are some formulas. If k is a constant, then the derivative of k is going to be kx plus c. Now, all these formulas, I would recommend having them in one place. So when you're doing your homework or you're taking a test, you can refer to these every single time. You don't have to go search for them. If you take the derivative or the antiderivative of x to the r dx, then we take the formula is x to the r plus 1 divided by r plus 1 plus c, provided r is not equal to 1. There's only one exception. This always works except for when r equals to negative 1. If r equals to negative 1, so in other words, if you have the antiderivative or the integral of x to the negative first, that's the integral of 1 over x, then this equals to the natural log of x plus c. And the natural log is actually an absolute value. Because remember, we can't take the natural log of a negative number. That's undefined. It doesn't exist. So in order to prevent that from happening, we always take the absolute value of the natural log. Okay, so the antiderivative x to the negative first dx is equal to natural log of x, absolute value of x plus c, and we're gonna ignore that. So just go with this formula right here. And we actually will not be assuming anything, so I'm gonna scratch that out. It's just fixing your notes, and we'll go with this formula. So the antiderivative of x to the negative first, which is same thing as 1 over x, is equal to natural log of absolute value of x plus c. Now, if you have an e function, and it's in this form of the integral of b e to the ax dx, we have to apply this formula, b over a times e to the ax plus c. Okay, so let's start with example number 1. Now, you really have to keep these formulas handy because you'll be referring to them at every single problem. So let's say we have the antiderivative of 5e to the x dx. So we're going to be using formula 4 because it's involving an e. So I'm going to rewrite this as the integral of 5e to the 1 times x dx. Now, why did I do that? Because I need an a value. And if there's no a value, it's assumed to be 1. So my b is 5, and my a is 1. So according to the formula, the antiderivative of this is going to be b over a, which is 5 over 1, or just 5, e to the ax, so that's e to the 1 times x, which is e to the x, plus c. To check, let's take the derivative of 5e to the x plus c. The derivative of 5e to the x, remember you keep the same term, so we keep 5e to the x and just multiply it by the derivative of the x, which is 1, so we don't have to write that. And the derivative of a constant is 0, so 5e to the x, that's exactly what we had in the antiderivative. That's correct. Next one is we want to find the antiderivative of 3 over x. Now the first thing we're going to do is we're going to pull the 3 out. So this is going to equal to 3 times 1 over x dx. Now by the formula, and again, these two are special formulas. By this formula, whenever we have 1 over x, it actually equals to the natural log of absolute value of x plus c. So this equals to 3 times the natural log of absolute value of x plus c. If I check, take the derivative of 3 times the natural log of absolute value of x plus c. By the formula we learned in the previous section, the natural log of x, its derivative is 1 over x, so this gives you 3 times 1 over x. Derivative of a constant is 0, so this just equals to 3 over x. Some rules for integration: write each variable on the numerator, which is similar to when we did differentiation, and write each variable using a rational exponent. Once again, same rules for when we did derivatives. All right, now let's do the next one. We want to find the antiderivative of this whole thing. So let's recap the rules one more time really quickly. If you have the antiderivative of x to the r, this equals to x to the r plus 1 divided by r plus 1. Okay, if you have the antiderivative of 1 over x, this equals to natural log of absolute value of x plus c. And I forgot the plus c over here. So let's take a look at the first one. We have negative 3x to the third. Now when we take the antiderivative of this, we're going to apply this formula. It's in the form of x to the r. Negative 3, that's a constant. So it's going to be negative 3 times x to the, follow the formula, r is 3, so r plus 1 is going to be 3 plus 1. And we're going to divide that by r plus 1, which is 4, which is 3 plus, and you know what, actually, just to keep it consistent, I'll write this as 3 plus 1. Okay, so this one, it's in the form of x to the r. So the antiderivative of that is going to be x to the r plus 1. 3 plus 1 is 4 divided by r plus 1, which is 3 plus 1. Plus, now the 6 over x, I'm going to split this up as 6 times 1 over x. And we know that the antiderivative of 1 over x is ln absolute value of x plus c. So this is going to be 6 times the natural log of absolute value of x. The 6x to the third power, we're going to rewrite this as 6x to the negative third. Remember that we have to rewrite everything with a variable on the numerator. So that's 6x to the negative third. If I take the antiderivative of that, then by the formula, again, this is x to the r power, x to the r power. Then it's x to the r plus 1. So we're going to have our constant 6 times x to the negative 3 plus 1. That's your r plus 1 divided by negative 3 plus 1. Okay. Then finally, we have 5 radical x. So we're going to write that using a rational exponent. 2, write each variable using a rational exponent. So we're going to have plus 5x to the 1/2. Now let's again follow the rule. We got 5 times x to the 1/2 plus 1 divided by 1/2 plus 1. So this rule here, we're going to be using it for the most part in this section. Let's simplify all of this. We're gonna simplify this in a couple of steps. So we have negative 3x to the 4th divided by 4 plus 6 times the natural log of absolute value of x. Let's not forget the plus c, the constant of integration. Then we have plus 6x to the negative second divided by negative 2 plus 5x to the 1/2 plus 1, that's going to be 3/2. And then 1/2 plus 1, that's going to be 3/2. And we got the plus c. We still have to simplify this. So this gives us negative 3x to the 4th over 4 plus 6 times the natural log of absolute value of x. 6 divided by negative 2 is going to be negative 3. So this is actually going to be minus 3. over x squared. This is going to be